Okay, so let's go ahead and finish this problem off. It took us a while to kind of analyze things and get everything together. But let me start with a fraction. So we're going to divide by x plus 1/2. We're going to do that synthetically. And so we have 2 and negative 11 and 20 and negative 43 and 44 and 4 and negative 16. Pretty nasty. All right, and so we'll start by dropping this 2. Negative 1/2 of 2 gives us negative 1, so that's negative 12. Negative 1/2 times negative 12, well, that's going to give us a positive 6, which is 26. Half of 26 is 13, so we get negative 13. So this would give us what here? 56, negative 56. And then half of negative, a negative times a negative is a positive. And then half of 56 is 28, right? And then that would give us 2, carry the 1, 72. Half of negative 72 is negative 36, which gives us negative 32. And then half of negative 32 is 16. And a negative times a negative is a positive. So we do, in fact, get 0. So that verifies that our eyes weren't lying to us. So negative 1/2 is, in fact, one of our zeros. All right, so how about we now, let's do the 4. So let's divide by x minus 4. And so when we do that, how about let's do one of the ones. So let's do x minus 1. So we're going to do that with that part right there. So negative is 2, negative 12, 26, negative 56, 72, and negative 32. So drop the 2. 1 times 2 is 2. That gives us negative 10. Negative 10, 16, 40, negative 40, right? Which gives us 32 and 32 and 0. So that verifies that 1 is a 0, but it was multiplicity 2. So let's do it again. And we'll do it to that quotient. So bring the 2 down. That's a 2. Negative 8, negative 8, 8, 8, negative 32, negative 32, and 0. All right, so here's where we're at after, and then we got 4, right? So let's divide by 4, right? So we have x minus 1, x minus 4, and we'll do it here. So 2, negative 8, 8, and negative 32. So bring the 2 down. 4 times 2 is 8, that's 0. That's 0, that's 8, that's 32, and a 0. Whew. All right, so here's what our function looks like after all that division. In terms of factored form, right, what we have is we have an x plus 1/2. We have x minus 1 squared, because there's 2 of them. We have an x minus 4, and then what's remaining here is a 2x squared plus 8. And to help us out here, I'll notice that 2 is common to both. So I'm going to factor that out and put it way out front. It's essentially our lead coefficient. All right. And the remaining zeros that we have basically solve that quadratic right there. And I think we've done that before, but let me do it again. Kick that 4 over. We got x squared equals negative 4. Take the square root of both sides, and we basically have plus or minus 2i. So my zeros, we have negative 1/2 is a 0, positive 1 is a 0, positive 4 of a 0, 2i, and negative 2i, right? And of course that has multiplicity of 2. So we have 1, 2, 3, 4, 5, 6, matching our degree of 6. And last but not least, that also means, let me sneak it in here, that we are going to factor this into, that's 2i and x plus 2i. So we got 1, 2, 3, 4, 5, 6 linear factors. Again, demonstrating that that theory that we had, that we can break them up into n linear factors depending on what our n is. So that, as you can see, hopefully wraps up. It's very similar to what we were doing in 5.2. It's just that what's different now is that some of our zeros are actually complex, and that kind of matches what we saw graphically, because visually I can see 1, 2, and then 3, 4 of my zeros accounted for, but I don't see myself crossing the x-axis anymore. So we were expecting two complex zeros, and there they are, all right, plus or minus 2i. All right, so we'll do some more examples. We'll try to get away from the technology because you guys know I usually don't let you guys use technology, and we've been using it very, very heavily. But there are ways I can still ask you some questions without it, and we'll investigate that in the next round of videos coming soon. See you then.